Good morning. In this video, we're going to reteach or review what you did on scientific notation before we went to Christmas break. You've done a little bit of work on 10 marks that's been scientific notation since we came back, so hopefully some of this is familiar. I'm going to review the objectives with you first pretty quickly. The first thing is understanding scientific notation. It's just a way for us to represent really big or really small numbers by using powers of 10. And right here we see a couple examples. The positive powers of 10, when you see a positive exponent here, 10 to the power of positive 6, allow us to write really big numbers, because if you take something like 2.5 and you multiply by a bunch of 10s, you get a much larger number. A negative power of 10 just means that we're going to do the inverse of multiplying by 10 a lot. And the inverse of multiplying by 10 a lot is to divide by 10 a lot. So if I took 2.5 and I divided by a bunch of copies of 10, that's what 10 to the negative fourth means, divide by the 10 4 times, I would get a much, much smaller number, a smaller decimal, because each time we divide by 10, the decimal moves left. Once we understand some of that and how to work with scientific notation, we're going to solve some real-world problems today where we have to perform operations like adding, subtracting, multiplying, or dividing. Let's take a look at the two examples today for our guided problems. Example 1 is going to take what we just talked about, understand what a scientific notation number really means, and you're going to take something like 3.7 times 10 to the 6th and try to convert it to decimal notation. That's just a fancy phrase for regular numbers. Or to take 78 million and convert it from a regular number, decimal notation, into this form, scientific notation. Pause the video and take a chance to try to figure problem or part 1 for the guided problems out on your own. Welcome back. So what we're going to do, we're going to switch over to the whiteboard here to take a look. And while the whiteboard's up there, take a look here. The first job, take scientific notation numbers like 3.7, flip the whiteboard. 3.7 times 10 to the 6th and convert that number into regular notation. Every time I multiply by 10, I've got 6 copies of 10 here that we could really write out. Every time we multiply by a 10, the effect is the decimal moves to the right by 1 place. The first time we multiply by 10, 3.7 times 10, it just becomes 37 after we've multiplied by that 10. We still have 1, 2, 3, 4, 5 more to place. That gives us 3,700,000. We have 5 times 10 to the negative third. Remember from earlier, a negative power of 10. That negative power of 10 tells us we're going to have to take 5 and divide it by 3 copies of 10. This really could be saying 5 divided by 3 copies of 10. That's another way to really think about what 5 times 10 to the negative third means. And if I take 5 and I divide it by 1,000, that's really what 10 to the third is. 10 times 10 times 10 gives us 1,000. 5 divided by 1,000, put that into a calculator, you're going to see 0.005. You'll notice, even though the exponent negative 3 tells us to divide by 3 copies of 10, the first time we divide by 10, that decimal point just moves to become 0.5. The next 2 copies give us those 2 zeros. So it's a little tricky. 10 to the negative third doesn't have 3 zeros. It only ends up having 2 zeros after the decimal point. Go ahead and pause the video again if you're not further and try to go the reverse way. How can I turn 78 million into scientific notation? How can I turn 0.0042 into scientific notation as well? What we should see, here's how I do it at least, 78 million. And the big rule we see here, the scientific notation says the coefficient, that number up front, has to be a single-digit number between 1 and 9. So I need to get the decimal point that's currently sitting here at the end of 78 million, and I need to get it all the way to 7.8. Because if this becomes 7.8, now I have the single digit coefficient that we needed. How many places to get there? That's 3 places. 3 more is 6, a 7th place, 7.8 times 10 to the power of 7. That 7 comes from needing to move 7 places. Now, if you took 7.8 and you multiplied by 10 7 times, would move back those 7 places, and that would get us to 78 million that we need this to be equal to. So to enter 7.8 times 10 to the 7th, today we've set up an equation. You'll see this looks like it's in equation tool mode. If you accidentally delete it, all you need to do is say insert equation, and now you can go ahead and start typing that 7.8. If you're looking for the nice multiply sign, that sits up here in the equation tools, right here, multiply times 10 to the power of 7. You'll notice scientific notation as you get older is really the one time we use the X symbol for multiplying. That's just kind of a relic of the past, but I could certainly go ahead and say 7.8 times 10 to the 7th if I prefer. Either or, they both mean the same thing. Last one we're going to run through real quick. This video took too long, I'm sorry. 0.0042. Again, to get this number to scientific notation, we really want to convert it so it says 4.2 times 10 to some power. So I need to get the decimal point to here. I'm going to go 1, 2, 3 places. This is a really tiny decimal number, so remember this is going to be a negative power of 10, because to get 4.2 to become a tiny decimal like 0.0042, we need to be dividing by 10 to move that decimal point to the left. Now that we have that in there, as we type this in, you're going to move to part 2 on your own. That's going to be a word problem, so start reading through part 2 as we enter this answer. You're going to pause the video again and take some time to work through part 2. In his basketball career, it says Kareem Abdul-Jabbar scores 3.8 times 10 to the 5th points, and it also tells us how much a current NBA player has scored. Pause the video, try to figure that part out. All right, welcome back. The first thing we're going to talk about, if we have word problems, a really important thing for word problems is to recognize we need to mark up the text. On a computer, I think the best way to do that is by highlighting. So I'm going to first find the question. Every time in math, I read through the problem once, but once I've read through it once, I want to identify the question. My job in this problem ultimately is to figure out how many total points these NBA players have scored. Every time I see the word total, I know total says I need to add here. That's what that word problem is telling me. I need to add if I'm seeing in total. This helps me understand now the only challenge. Kareem's points and Giannis's points, they're in scientific notation. Not only that, they have different powers of 10. Whenever I see that, I'm just going to go ahead and convert these two numbers into regular notation. And I just think that's a little easier if they have different powers of 10. You may have a different method to do this. If you do, great, keep using it. 7.8 times 10 to the 4th, you should recognize is 78. After I multiply by 1 copy of 10, I still have 3 more copies of 10. That tells me that, all right, my numbers are off here. The problem's got to change to 7.8 times 10 to the 3rd and 3.8 times 10 to the 4th. Giannis wishes he had scored 78,000 points. So as usual, Mr. Doherty made a mistake. He's actually scored 7,800 points in his career. Kareem has scored 38,000 points back when he played. So when you get the problem today on your document, you're going to see different numbers than I had up here at first. Kareem's 3.8 times 10 to the 4th. Giannis 10 to the 3rd. Sorry about that mistake. Now that we're up to date, what do I need to do to get total? I need to add, so I'm going to bring that 7,800 that Giannis has scored, pull it in here, and we get, using the standard algorithm, that's what we're doing here when we add the way you were always taught. That's called the standard algorithm. 8 plus 7 gives us 15, carry the 1. Together, they've scored 45,800 points. So they've scored 45,800 points, and if I wanted to write that into scientific notation, we'd see 4.58 times 10 to the 4th. Video took a long time. Thanks for getting through it with us. Good luck on the rest of the problems today, and call me or Mr. It over.